Lesson 2, Part 2, Video C. Let's jump right into proving
whether or not a function can be continuous. So
the basic rule is this. The statement right here is how we prove
something is continuous, and that is if the limit as x approaches c of some function
equals the function value
f of c. So if you can draw the function without picking up your pen or pencil, at any point that you're looking at, then the function value or the y value should be the same, right? There is no weird scenario happening. We can prove this through 3 small steps. Step 1,
we need to prove that the limit itself exists. The limit as x approaches c from the left
is the same as the limit as x approaches c from the right.
Meaning we can't say a limit exists until we can prove the limit itself exists. So we check it from the left, we check it from the right. If it's the same value, boom, yes, the limit exists. 2, we also need to make sure that the function itself
at the value that we're looking at, so c in this case, actually exists. Is it defined or does it exist?
And if so, then step 3, which you saw above, if the limit that you found is the same value of f of c, then boom, it is continuous
at that point.
So we literally would test the continuity of a function at a specific value
by doing just this, all right?
So we could do an example. Let's say the function is f of x
equals x squared minus 8.
And I'd like to know,
is f of x continuous? So as you learned in a prior slide, this is a polynomial, so you could automatically say yes, because all polynomials are continuous.
But if you want to prove it, you got to show me the steps.
So let's just pick a point. Let's let
c equal, let's say 3. So step 1.
Does the limit as x approaches 3 from the left
equal the limit
as x approaches 3 from the right?
Well, if we plugged in a table of values and we got closer and closer to 3
from the left direction, so I put 2.5, 2.9, 2.99, 2.999, I would notice that I get closer and closer to the value of
3 squared, which is
9 minus 8, which is 1. And I would find out if I do the same thing from the right side, I would also get the value of 1. So therefore, yes, the limit itself does exist. Step 2.
If I plug in the value of
c, does the function exist? Well, sure does, because when I plug in 3 squared, 9, minus 8 equals 1.
So step 3, the limit we found out equals 1, and the function value is also 1. And since the two of them are the same number,
they are equal. And we can say f of x, therefore, these 3 little dots,
therefore f of x
is continuous.
So as you can tell, that was a pretty simple example. The question is, will this always be true? So you'll most likely see this as an AP problem where they're asking you in some way, shape, or form to investigate continuity. So let's take a closer look at this
little guy right here at the bottom of the screen.
So this is a piecewise function, f of x. And in this scenario, f of x equals x squared minus 4 plus 2. And it also equals 3. But when does it equal these? So it equals x squared minus 4 all over x plus 2 whenever x is less than negative 2 in union with any time that x is greater than negative 2. So notice it does not include what happens when x equals 2. So when x equals 2, the value is going to be 3. So you can graph this function yourself and investigate it, right? But you really should just be checking both of those functions. So let's look at the first function, x squared minus 4. All over x plus 2. So we should know already that we can break this down as x plus 2, x minus 2. And we can factor those down. We're down to x minus 2. So if I plug in the value negative 2, I get negative 2 minus 2 equals negative 4. So I know that the value of this function is negative 4 as it approaches x equals negative 2, right? So it should be approaching the value of negative 4. Let's check if that's the same thing that happens when x actually is negative 2. So let me just adjust that because I should have written that better. So when x equals negative 2. All right, so let's take a look. When x equals negative 2, we have to say the value 3. So that means my function up until negative 2,
X equals negative 2 here.
it approaches, as we saw in the prior example, we plugged in negative 2 squared, we plugged in negative 2 minus 2, and we got negative 4.
So that means it should be getting closer and closer to the value negative 4, right? That's where it's headed.
But we find out that when we plug in x equals negative 2, this function is supposed to be at a height of 3. 1, 2, 3. So it's actually here, which means I can't draw this solid line.
I have to draw an open circle
So my function is actually going to continue, if you really graphed it,
in this direction like that.
but this created a jump discontinuity. And by checking what happens at x squared minus 4 over x plus 2 and looking at the value of 3, we notice that
When x equals negative 2, f of x is discontinuous.